Here we have a potato cannon that shoots a potato at 60 meters a second, and the question is what's its range, which is the same as asking what's the horizontal distance that it travels in the air before it lands. If it was launched horizontally, we'd be able to instantly put information into the horizontal and vertical parts of our brackets so that we'd know exactly what to do. The horizontal motion is still steady speed motion, and the vertical motion is still accelerated due to gravity. The problem here is that it's not launched horizontally and it's not launched vertically. It's launched a combination of those two. So, we have to draw a triangle and find the components of its motion at the beginning of time in the problem that are in both a horizontal and a vertical direction. Here, since it's launched at 60 meters a second at a 30-degree angle, we're going to have to find out what is the initial velocity of the projectile upward, and what is the constant velocity of it to the right. And the only way to do that is to do some trigonometry. So, we can make these statements right away. The sine of 30 degrees from there is the opposite over the hypotenuse. This we could call an r velocity, or a hypotenuse. The sine of 30 degrees is Vy over 60. 60 times the sine of 30 degrees is Vy. It comes out 30 meters a second. The horizontal component of the velocity can be found using the cosine. Cosine of 30 degrees is Vx over 60. So Vx is 60 times the cosine of 30 degrees. Vx comes out 51.96 meters per second. Those two quantities, Vx and Vy, can be substituted into our horizontal and vertical brackets. The horizontal motion, since it's steady, is always going to be at 51.96 meters per second. The vertical motion is going to start out upward. Vo will be 30 meters per second. And because it comes up and back downward and accelerates the entire time because of gravity being downward at -10, the final velocity of the object, when it gets to this point at the end of its fall, will be just as much downward, -30, as its velocity was at the beginning of time, upward. This upward 30 meters per second found here matches this downward 30 meters per second. Finally, we need to know how long it's going to take in the air to go up and come back down. So we now have enough information to find the time. The final velocity is -30. It started out at +30. Gravity is -10. Be careful here. This is -60 equals -10t, and t comes out 6 seconds. If we substitute that in our d equals vt, for our horizontal motion, we end up with the range, if we round this to 52, times 6 seconds, we end up with a range, horizontal distance, of 312 meters. Now we know that our cannon launches at 6.90 meters per second. And the question is, if we launch it, not horizontally, but at a 25-degree angle, how far away will we have to put a target at the same height as the launch height so that the ball will land exactly at the target. Here's our cannon, set to 25 degrees. Since we're not going to launch it horizontally or vertically, but a combination of the two, we have to solve this triangle to figure out how fast at the beginning the ball is rising and how fast the entire time it's moving to the right. Meaning we have to take the sine and cosine of 25 degrees to find the components of our vector triangle. Just like you did in problem number 7 about the potato cannon, you should now be able to arrange this information into horizontal and vertical components of motion. Here, the horizontal velocity is constant and the vertical velocity is affected by gravity. At the beginning it is upward at 2.916, and at the end of its projectile path, when it enters the target, we hope, it's negative 2.916. Now we can solve for the time and use it to find the horizontal distance. Here we've used the information given to find the amount of time it will take for the ball to enter the target and the distance away from launch that the target will be horizontally, which is 3.72 meters. Since we know the ball is supposed to be launched 3.72 meters when we have it set to 25-degree launch, I just set up a target that is 3.72 meters away. There's 1 meter stick, 2, 3.72 is the center of this garbage can, and it's at the same height that it was going to be launched from. Now that we've found the range was 3.72 meters, the next question we should ask is, how high does the ball go at its highest point, which is in the center of the 3.72 meters? Given that this is a question about the vertical position of the ball, we can pretty much ignore all of the horizontal information that we had from before, as long as we remember that our target, which is going to be my son, should be in the middle of the ball's path, which is 1.86 meters away. What we want to know is the vertical distance that the ball will rise. We know that it starts out going upward at 2.916 meters per second, and that in the middle it comes to a stop, at least vertically. It's always moving horizontally at 6.253 meters per second, but again, we don't need to know that right now. Gravity will pull down at 9.8, and we can figure out the vertical distance that it will travel to its highest height. Here I've used kinematics to calculate that the highest height above its launch height that the ball will reach will be 0.4338 meters, which will occur in the middle of its flight path, at which point it is 1.614 meters off the ground. By now we calculated that the target height that we should reach is 1.614 meters off the ground, and it should reach that highest height, which is his height, at exactly the distance he is away from the cannon. So, at this point the ball should shoot over his head, just barely graze his head, and then head into the same trash can that we hit before. Let's try it. Are you ready? Here we go. 3, 2, 1.